This one is going to be exactly the same as what I just worked, except that you've got 2 instead of 1. So you can see everything else is the same. Like the numbers are all the same. So if you're thinking ahead and you're kind of thinking about the numbers, and if I just kind of copy these numbers down a level, all right, so I've got all these numbers copied down. And again, it's asking me about that H2SO4, just that like that last thing was asking me about H2SO4. And so all I'm going to do is the same exact setup. So I'm actually going to copy this whole setup right here. Make it a little smaller to fit. But what I'm doing is I don't go to moles of HCl. This time I'm going to moles of H2SO4. So you'll notice I took the liters of NaOH, which was this turned into liters, times that 0.250 number. That gave us moles of NaOH. And so once we had the moles of NaOH, we could go into moles of anything. Now this time, because there's a 2 in front, I can do a 2 and a 1. So this number will actually be half of that number above. So I've got 0.03523 times 0.250 divided by 2. And that gives me that 0, which is exactly what you'd expect, right? It's half. And then at the beginning, it gave us how many, convert that into liters, 0.050 liters. That gives me my moles per liter, and I'm going to divide it by 0.05. Oops. 0.00440375 divided by 0.05. And so I don't know if you're seeing this, but that's half of this number, which makes sense because of the 2 coefficient, 0.00, 0.08, 0.0881. So you can see how coefficients make a difference. This was 1, and I got that answer, but then this one, it's half. Like the coefficients really matter. You got to get them right.